So, hello everyone. So, in this lecture, I will discuss repulsion motor, its characteristics and applications. In previous lecture, we have discussed the construction and operation of the repulsion motor. So, construction and operation part has been covered. Now, we will discuss the characteristics and applications. So, going forward, so we discussed the speed torque characteristics of the machine, or we will discuss the torque equation of this machine. From the previous lecture and discussion, it is clear that production of electromagnetic torque in case of repulsion motor, the brush position is playing very important role. And you can say for production of electromagnetic torque, the brush position must not be along the direct axis or quadrature axis. This means alpha should not be either 0 or 90 degree. In both cases, the developed torque will be 0. So it should not be either 90 degree or 0 degree. Alpha should be in between 0 and 90 degree. So brush can occupy any intermediate position between 0 and alpha equal to 90 degree. And for the sake of simplicity, we assume that brush axis is vertical and will shift stator field axis at some intermediate position, which will be shown in the next figure. In the next slide, I will discuss this part. So we can say it has no effect, right, on the operation and the calculation of motor. So we can say its effect on the operation and calculation of the motor torque and all part, but it greatly reduces the calculation effort. So we can by making certain assumptions, we can get better torque equation calculations, and we can reduce the overall calculations, right? So you can see the diagram. It has d axis, right, and it has brush axis, like this a axis is giving the brush axis, and this corresponding alpha is also shown there. So ns is their number of turns on the stator field. So you can say from the figure, the field axis is making an angle alpha with the brush axis, right? And if suppose we consider Is and Ns are the stator field current and effective number of stator turn, so what will be the stator MMF? The stator MMF will be the current multiplied by number of turns. So it is Is into Ns, and it is directed along its axis. You can say it is directed along its axis. Is Ns, it is directed along this, right? You can see from the diagram and the figure which is shown, showing the axis direction. And this stator field is now replaced by two fictitious stator coils, coil F, it is shown here, coil F, and coil T, it is shown here, right? So you can say the stator field is replaced by two fictitious stator coils F and T, such that the stator MMF, that is Is Ns, remains unchanged in magnitude as well as in the direction. So direction of Is Ns will not change, as well as magnitude of the Is Ns will also not change. So now we calculate the torque. So we going forward, we can calculate the torque. Now, so torque equations for repulsion motor can be discussed here. So number of turns in the coil T, suppose it is Nt, and the MMF in coil T will be how much? Whatever the current flowing across the coil T, as well as the number of the turns in the coil T. So number of turns are Nt and coil current is Is. So MMF of the coil T will be Is into Nt, right? And component of stator MMF along the brush axis will be, so it is cosine of alpha, right? Cosine of alpha. So it will be Is Ns cos alpha. So Is Nt must be equal to Is Ns cos alpha. So we can say, so number of turns in the coil will be Ns cos alpha. So similarly we can find for the number of turns for the F coil. There are two coils now, T and F. So for F you can find one is cosine angle and another is sine angle. So for T coil it is ns cos alpha, and for F coil it is ns sine alpha. So these are the two values we obtained in terms of sine and cosine of the alpha. So we all are aware that the magnetic axis of the rotor winding and coil T coincides. This is fact. And the flux produced by the coil T will link with the rotor winding. This is also true. This means that the rotor MMF will be equal to MMF of the coil T. So rotor MMF will be equal to MMF of coil T as per the Lenz law. So rotor MMF will be how much? MMF of the coil T, and coil T MMF was IS NT. So NT was ns cos alpha. So we can from this you can get rotor MMF is equal to IS ns cos alpha, which we determined the value of NT in previous slide. So you can replace the value of NT by ns cos alpha. So rotor MMF will be IS ns cos alpha. Now what will be the value of electromagnetic torque? So electromagnetic torque will be K equal to K stator field strength, rotor field strength, and sine of the angle. So where K is the constant, so sine of the angle, which is angle alpha. So you can find electromagnetic torque is equal to KSIS K ISNS upon ISNS into ISNS cos alpha sine alpha. So the equation can be like this. So resultant electromagnetic torque can be obtained. So from the equation we can conclude that torque in the repulsion motor is equal to K by 2 ISNS square sine 2 alpha, right? So now if we analyze the relation between torque and displacement alpha, so we can get from the torque equation the repulsion motor, the maximum torque is achieved when stator and rotor magnetic axes are replaced or displaced from each other by 45 degree, right? So the variation of the current and torque with respect to different positions of the brushes can be obtained. You can say this is the torque equation, this is torque and this is the current IS, and you can get the position alpha 0 degree, 30 degree, 60 degree, and again 90 degree. So torque value is 0 at 90 position and torque value is 0 at 0, alpha equal to 0, which we have discussed. So maximum value will be obtained at angle alpha is equal to 45 degree. So it must be noted that rotor current is maximum when the brush axis and the direct axis coincide each other. So we can say the current in the rotor will be maximum at the condition when the brush axis and direct axis coincide each other, right? And rotor current is 0 when the brush occupies a position in quadrature with the direct axis. So rotor current will be 0 in that case. And maximum torque in case of repulsion motor is achieved when the stator and rotor field axes are at 45 degree apart, right? So if the alpha is 45 degree, you can get a maximum torque in case of repulsion motor. So maximum torque will be achieved at this position only. So now we will discuss, we have discussed its torque equation and how the torque relation is responsible with respect to alpha. So on the basis of its characteristics, on the basis of its application and on the basis of its operation, there are a number of applications which this machine has. So repulsion motor can be used for various places. It can be used in various places, and it can be used in some loads which requires high starting torque, like you can have hoist, you can have lifts, etc. So this application can be can accommodate repulsion motor. So such applications will accommodate repulsion motor. So you can say repulsion motor has application in such places or such kind of requirement. So value operators, it has repulsion motor has application in value operators, and repulsion motor also have application in form motor applications. They have very better application in hoists and lifts, and you can say the repulsion motor are also used in floor maintenance machines. There are number of applications in floor maintenance machines, and this repulsion motor is also used in air compressors. So another application of repulsion motor is air compressor. And you can say this repulsion motor are also used in laundry equipments, and they are also used in mining equipment. So these are the certain applications. You can also find some more application of this machine. So these are the certain applications, and this machine is applicable in number of fields because of its characteristics and because of its structure. So this was all about its characteristics and application. Thank you. Thanks a lot.